In this video we're going to continue with the topic of exponentials and logarithms b, and we're going to look at another property of logarithmic functions. So to start with, I'd like you to complete a task similar to task 2 in the previous lesson. So I would like to complete this table of values for log to the base 10 of a over b, log to the base 10 of a over log to the base 10 of b, and for log to the base 10 of a minus log to the base 10 of b. I would like you to give each value correct 3 decimal places, and you can see the different values for a and b here. So if you pause the video just now and fill in the table in your notes using your calculator. Welcome back, folks. So hopefully you've got on well with that and you've substituted all of these in. So the first one we can see here, that would be log to the base 10 of 12 over 4, which is log to the base 10 of 3. And that is equal to 0.477. For the second one, log to the base 10 of 12 over log to the base 10 of 4 is equal to 1.792. And the subtraction of the two separate logarithmic functions is 0.477. The next row, we should have 1.114, 4.700 and 1.114. And in the last row we should have 0.699, 2.465 and 0.699. And hopefully, folks, you've noticed that your first column and your last column have given you the same values. So we can conclude from here that log to the base 10 of a over b is equal to log to the base 10 of a minus log to the base 10 of b. Now we can then generalise that for any base, we'll call it x, and we can say that log to the base x of a over b is equal to log to the base x of a minus log to the base x of b, where x, a and b are all greater than 0, they are all positive. So to summarise, if we subtract logarithmic functions with the same base numbers, then the terms can be combined by dividing the arguments. So we'll have a look at a checking example like we did in the previous lesson as well. So this time we're having log to the base 2 of 8 minus log to the base 2 of 4. And given what we know from above, from this property, 8 divided by 4 is 2, so that's the same as log to the base 2 of 2. Now if we take each side of that equation and make sure that those are actually equal. So log to the base 2 of 8 is 3 and log to the base 2 of 4 is 2. Remember, 2 cubed gives me 8 and 2 squared gives me 4. So 3 minus 2 is 1. Over to the right hand side, log to the base 2 of 2, so 2 to the power 1 is equal to 2. So we can see that yes, that property does work there. Okay. So let's take a look at some examples. So example 1, we want to simplify log to the base 7 of 15 minus log to the base 7 of 3. So given the property that we've learned above, you can see that we're subtracting logarithmic functions with the same bases, so we can divide the arguments. So 15 divided by 3 is 5, so that expression simplified is log to the base 7 of 5. And example 2, we want to simplify log to the base 4 of 6 minus log to the base 4 of 3. Applying the property above, we can divide the arguments. So 6 divided by 3 is 2, so that gives me log to the base 4 of 2. And I can actually evaluate this one. I can say to myself 4 to the power what gives me 2. And remember, that's the square root of 4, which is 2, so that is 4 to the power a half. So the value of that expression is a half, which is my final answer. So just now would be a good time to pause the video before the screen goes blank, copy these examples down in your notes and complete the assigned exercise for today.